Hello everyone. In this segment we will discuss about stable and first stable system. Now let us define what do we mean by stable system. A system is said to be stable if for every bounded input it should produce a bounded output signal. Now bounded means its magnitude should be less than infinity or it should be finite. So the necessary condition will be if we have an input signal whose magnitude is less than infinity, then it should produce an output signal y of t which is again less than infinity. So the condition is bounded input, bounded output. If this condition is satisfied, the systems are known as stable system. Otherwise, they are going to be astable systems. Based on that, we can write a system is said to be stable or said to be bibostable system. That stands for bounded input, bounded output stable system. Now the question arises, how will you check whether the given systems are stable or unstable? So the first condition is input and output should be finite, that's fine. Now let us come across actual mathematical equation by which we can determine whether systems are stable or unstable. In that case, if our system is continuous time, then the necessary condition will be integration, that is area under the curve of impulse response, that is mod h of t dt should be less than equal to infinity. Similarly, if we have a discrete time system, then the necessary condition to check its stability becomes summation of n for the limit -2 plus infinity mod hn should be less than infinity. If these conditions are satisfied, the systems are said to be stable, otherwise unstable. Now this h of t and h of n is nothing but, I will write it here, it is known as impulse response of the system. Now how will we get this term impulse response? For that case, let us understood this with the help of system. Now if this is a system, I am assuming that I have an input signal as x of t. Now if the input to the system is x of t, its output response becomes y of t. Y of t we can write as output response. Now if I replace x of t with input signal as impulse function, then whatever the output term we are getting, that output term is known as impulse response. Now this impulse response is due to impulse function, hence it is known as impulse response. So by replacing x of t by d theta t, we can get impulse response as h of t. Similar case, if I assuming input signal as del n, it becomes h of n, that is impulse response of discrete time system. Now based on this condition, let us come across few examples of checking whether the given systems are stable or unstable. Now here we have the first example, y of n is equal to ax square n. In order to check whether the given system is stable or unstable, we have the condition summation mod hn should be less than or equal to infinity. Now in this example they haven't given us h of n directly, so we try to obtain h of n by replacing input signal with del n. So if x of n is del n, that output function y of n becomes equals to h of n. So I can get this function as h of n is equals to a, instead of x of n we can write del square n. Now we have to sum h of n over the limit -2 plus infinity. So I am considering the first case. If n is 0, we will get the first sample value h0 as a del square of 0. Now we know the property of impulse function. It exists only for single value of n, that is at n is equals to 0. I am writing it here. del 0 is 1, and for other values del of n or del of t is going to be 0. So we'll get the first term as del 0 is 1, 1 square is 1, so this value is going to be a. Now if n is not equals to 0, we'll get hn. I'm writing only h of n because it is not equals to 0. We'll get this value del of n is 0, and 0 into a is going to be 0. That means for the all remaining value, the value of h of n is 0. So when we add these all terms over the range, we'll get only the value of a plus 0 plus 0 plus so on up to plus or minus infinity. That means this summation holds a unique value as a, and a is going to be finite. Therefore the given system is said to be stable system. In this case, we have to look after the property of impulse function. Del n will have an amplitude 1 for n is equals to 0, otherwise the amplitude is 0. Now let us recall the second example, y of n as axn plus b. I am putting that very directly. hn becomes a instead of x of n del n plus b. Now for the first case, if n is 0, h0 will be a del 0 plus b. We know del 0 is 1, and to a plus this term as a plus b. And if n is not equals to 0, we'll get hn as a into 0 plus b. This is 0 plus b, it will be b. Now we'll add all those sample value. We'll write this is minus 2 plus mod hn will be a plus b, and for all the values it is going to be b, so we'll get b plus up to infinity. That means now it will have an amplitude, it is going to be b. Now if you consider this condition, it will never end. That means this series never converges. Now if it never converges, definitely it will approach to minus infinity or up to plus infinity. That means its value is not going to be less than infinity. So in such cases, the system is said to be unstable system. We are not getting a unique solution, so it is going to be an unstable system. Let us see a few more examples on this. We have next example for continuous time signal. Here directly h of t is given, so we'll write the important condition. We know that integration mod ht dt should be less than infinity. So we'll substitute those values. This is e raised to minus a mod t dt. Now here we are getting mod t, that means it will have two values. One is less than 1, or that is going to be minus values, or it can have positive values. That means mod t can have two values, either plus t or minus t. So we'll simplify this term. One range we are getting from minus infinity to 0. In this case, t will be minus, and next case we'll put it from 0 to infinity. In this case, t is going to be positive, so we get e raised to minus a plus t dt. Now we can simplify this term. This is minus infinity to 0, e raised to plus at dt, plus this is 0 to infinity, e raised to minus at into dt. We'll integrate this term, e raised to at divided by a, plus this is e raised to minus at divided by minus a, for the limit 0 to infinity. Let us put the limit values. 1 by a I am taking outside, upper limit 0, so this is going to be e raised to 0, minus lower limit e raised to minus infinity, plus this is minus 1 by a, upper limit infinity, we will get this term as e raised to minus infinity, lower limit 0, e raised to 0. Now we know that e raised to 0 is going to be 1, e raised to minus infinity will have a value 0. If I consider those values, we will get this term as 1 upon a into 1 minus 1 upon a into minus 1. So this becomes 1 by a plus 1 by a. If you take a as common, this will be 2 by a. Now 2 by a will definitely less than infinity, provided that a should not be equals to 0. Therefore, we can say now the system is stable system. Now this is the example that we are assuming for continuous time signal. Let us see one more example on this. Here we are having the first term, y of n is equals to cos xn. H of n is not given. Replace h of n with del n. I am writing directly. H of n becomes equals to cos del n. Now for n is equals to 0, we will get the first sample value h0 as cos 0, and cos 0 value we know that is going to be 1. Now let us come across, this is going to be cos 1, so we'll hold this value as cos 1. Next, for n not equals to 0, we'll get hn can have cos of, now del n is going to be 0, that means it will have an amplitude 1. So summation hn, now it becomes addition of all those sample values, it will be cos 1 plus 1 plus 1 up to infinity. Now if you see, the series never converges, that means it will remains continuous. Therefore system is said to be unstable. Let us come across this example. Here again they haven't given h of t directly, so I can write h of t is equals to t into del t. Now if you want to integrate this term, now basically we have to perform the integration. So if I consider the first value, we can assume the answer directly. T0 if I put, we'll get h naught, which is going to be this T0 into del 0. Del 0 is going to be 1, that means we'll get the answer as 0. But if t is not equals to 0, we'll get h of t is equals to, this is going to be t into del of 1 or maybe 2 or any value is there. But this value is 0, and 0 into this is going to be 0. Now in any of the cases, we are getting the sample value as 0. How will we predict whether it is stable or unstable? So if you see here, the output is directly depends upon x of t, but it again depends upon time period. So if the values of t goes on increasing, automatically y of t response will goes on increasing. Hence we are saying this as unbounded. And if it is unbounded, definitely the system is going to be unstable system. How we have predicted this? This is going to be an unbounded system, or unbounded output is there, therefore the system is said to be unstable system. Thank you.